Okay, we're going to look at graphing the solution of the system of inequalities and labeling its vertices. There is a lot to unpack in this question. The first thing is to recognize what type of equations you have. This first equation is a circle, and so let's talk about that really quick. The general form of a circle is x minus h squared plus y minus k squared is equal to r squared. So these values h and k give you the center of the circle, and then r gives you the radius. And so in this case, I have a circle that has a center at 0, 0, because there is no h and no k, so centered at the origin, and the radius is the square root of 25, which is 5. And so to graph this, let's go ahead and put that, we'll put it right here, and I won't have a perfect circle by any means. Let's actually move that down a little bit. And I wouldn't expect you to have a perfect circle either. But we'll put the center on the graph, although that's not actually part of the circle. We'll use it there for reference. 1, 2, 3, 4, 5. And then just count out every direction. 5, up, down, left, and right. And then draw your circle kind of the best you can. And that will suffice for here. I missed this bottom point here. Okay, and then this says x squared plus y squared is less than 25. So the there's kind of two ways to decide where to shade, because let's actually go back. So before we draw our circle, we have to decide if it's a dashed or solid line. And in this case, our line should be dashed because it is less than. So we'll draw our dashed circle. It's good I got a second shot at drawing my circle. And then we have to shade inside or outside. Well, the shortcut is if the variables are less than 25, so if the variables are less than the radius, then we're always going to shade inside of the circle. Another way to do this is to think of a test point. And so if we test any point, let's test a point inside the circle, and we do 0 squared plus 0 squared is less than 25. So is 0 less than 25? This is true. So we're going to shade where things are true. So because the point 0, 0 is true, and it's inside the circle, everything that's inside the circle must also be true. So we'll shade there. Okay, the second inequality is a line. And so we can graph lines by solving for y. So we have 2y is greater than or equal to negative x plus 5. And then y is greater than or equal to negative 1/2 x, and then plus 5 over 2. It looks like. Okay, and then we can graph that line. So plus 5 over 2, that's 2.5, so that's here. And then we're going to go down 1 over 2 to get this line. So we'll go down 1 to 1.5 over 2. Let's go the other way. We'll go up 1 over 2. And we'll sketch this line in. And it is a solid line because it is greater than or equal to. And you can also see that here, it's greater than or equal to. And so we'll draw in this solid line. Try to make it go through those points. And then we want to shade above. The best way to do a line is to use the y equals shortcut. So if it says you solve for y equals, or in this case y is greater than or equal to 0, then you go to the y-intercept, and if y is greater than, you shade above. And so we're going to shade up here. Let's highlight. And you would highlight everywhere above the line. But then my solution is just where the overlap. So the solution is in this section here where we have overlap. So all of the green gives me my areas of solution. And so what that means is any point that is either on this line or in the shaded region will make both of these inequalities true. That's what we mean by the solution set. So that's when it says graph the solution to the system of inequalities. That's what we're looking for, this shaded piece here. Really the whole graph, but the shaded piece is where the solutions lie. Okay, now if we want to find the vertices, now it's a system of equations. So to label the vertices, we're going to solve the system. Okay, so what does that mean? Well, that means I have x squared plus y squared is equal to 25, and x plus 2y is equal to 5. So we're looking for this point exactly and this point exactly. We're kind of close to it with our graph, but if we do it algebraically, it'll be exact. So let's solve by substitution. Let's say x is equal to negative 2y plus 5. And so then I have negative 2y plus 5 squared plus y squared is equal to 25. And then we can FOIL. So that's, let's go ahead and write that out. And we get 4y squared, and we get minus 10y. Minus 10y gives me minus 20y plus 25 plus y squared is equal to 25. And this is nice because my 25s do subtract to 0. And so it'll be a little easier to solve this guy. I can combine to get 5y squared minus 20y is equal to 0. It's a quadratic, so we'll look to factor, which we can take out of 5y. And that gives me 5y and then y minus 4. And so that gives me solutions of y equals 0, because 5y equals 0. And then y is equal to 4. And that comes from setting y minus 4 equal to 0. So we can kind of squeeze those in. And that gives me that. And then y minus 4 gives me this. Whoa. Okay, and as your graph said, well, y equals 0, that's pretty close, it looks like it. And then y equals 4, that's pretty close too. So it's not a perfect circle, it's not a perfect line. So I'm feeling good about these solutions here. To find the x value, just plug them in anywhere. Let's use this equation right here to find x. And you may be able to guess from your graph, but let's find exactly. So x is equal to minus 2 times 0 plus 5. So x is equal to 5. Gives me the point 50, which looks to be true. And then here x is equal to minus 2 times 4 plus 5. And so that gives me the point x is equal to negative 8 plus 5 is negative 3, which also looks to be true. Negative 3, 4, so I'm just a little low on my graph. And so that gives me my two vertices. And so once again, these are not the solutions. These are just two vertices where the graphs intersect. Let me get my other y value here. So I have my two vertices here. My solutions are the points that are inside of the shaded region or on the solid line.